Hi everyone, my name is Mrs. Lawler and Mr. PK is going to be out through the new year. So I've decided to help him along and he's fine, by the way. But I'm going to help him and go through and make sure you guys end up on the same place as my kids, so that you know that we always plan out the same thing. So we're going to go through this Plate Tectonics Web quest. I'm going to go through each of the links with you and make sure you have all the correct answers, so that you guys can all turn that in. If you guys want to take a moment now and open this up in your Google Classroom, that would be great. Again, if you're a part of first or seventh period, you're going to be coming into my classroom so that you guys can interact with my students. And then fourth period, we have a very diligent substitute, and you may know her. She's probably covered some of the classes with Mr. PK. And then periods 2 and 9, you're going to have Mr. Atkins and Miss Parsons in there with you. So no real change there, other than you might be watching this video. So what we're doing today is we're going to go through this Plate Tectonics Web quest. And you might have started this. I just want to make sure everyone has all the information that they need. So the first thing is we're going to click on these particular links, and it's going to take us to these sites. So the first one is this. And what we're doing is we're figuring out what A, B, C, D, and E are. Okay, and we're going to fill in the answers down below, but I want to show you where they are. So the crust is letter A, and the crust is where we live. So we live on what is called a continental crust. We also have a lot of ocean on our Earth, and those are the oceanic crusts. Okay, right below the crust, and sometimes we see a break in our crust, and sometimes we see what's inside the mantle, and that's called lava when we see that. We have two different sections of the mantle. So that is letters B and C. These two sections are both liquid. But if you ever made pudding, or if you ever had sauce or soup that is like cooked and you get that thin layer of goo on the top, that's sort of this upper mantle. We call that the asthenosphere. Okay, and then those both sections are liquid. We go to the outer core, which is also a liquid. It is made up of really hot iron and nickel. And then our inner core is in the middle. And because of all the heat and pressure of the whole world kind of pushing on it, it is even hotter iron and nickel, but it is solid. But it is extremely hot. Because the middle of our Earth is so hot, it allows us to spin every 24 hours and also go around the sun every 365 days. So again, the inner core is solid, outer core is liquid. The mantle are both liquid, and the crust is solid. Okay, so hopefully you guys filled in A, B, C, D, and E. Okay, which is the crust, the mantle, the outer core, and inner core. If you wanted to, you could also put down what type of layers they are. We will have a quiz on this next week, so you're able to use all of your notes for that quiz. So it may also be helpful for you to kind of click on those and say, oh, I remember, that's the answer to that. Or just review this video again. All right, now we're going to go to the second link. And now we're learning about what our planet looked like before and what it looks like now. So the question on the web quest is, does A depict what our world looks like now? And the answer is no. Okay, B looks like their answer is now. So the answer for the next question is false, and the answer is B. When we click on this and we go, oh yes, we did it, we got it correct based on their question, okay? And how do we know what the world looked like 250 million years ago? Well, we looked at this, and there's this gentleman, Alfred Wegener. He was a scientist in the 1900s. About 1920, 1915, 1920, he came out with a book called The Origins of the Continents and Oceans. He called that supercontinent Pangaea. And why he called it Pangaea is I'm not 100% sure about that, but the reason why he said that they were once all together is, one, he said that if you look at South America and Africa, they look like they fit together like a puzzle piece. And other continents look like they could fit together like puzzle pieces. He also looked at fossils and saw that there were fossils on South America, and the same fossils were actually on Africa. So he said they must have been together at one time. He called that big landmass Pangea. Okay. And then his name, the scientist who it was Alfred Wegener. Okay. So when we go back to this, all right, the answer for this one would be false. All right, I forgot to make that red. It's called Pangea. A was actually called Pangea. So 250 million years ago, the continents of the Earth were joined together in one landmass, and the scientists called it Pangea. Okay, the scientist named Pangea was a German scientist by the name of Alfred Wegener. Okay, now we're all the way up to part 3 already. So part 3 is there are different types of earthquakes that can occur, or different types of plates out there that can eventually lead to an earthquake. And that's what we're going to look at now. So when we go to this site, so this is a map of all the different plates around the world. There are 7 major plates and between 11 and 18 total plates altogether. So the first picture that you have on there is this one, where they're sliding and slipping and sliding past each other, which is called a transform boundary. This is what's happening in California, is we have the San Andreas Fault. And what it is it's slipping it past each other, and it'll eventually separate part of California off into the ocean. That's how much separation there will be from these two land masses sliding past each other. The second one is occurring in our Atlantic Ocean. So if you look at the Atlantic Ocean right here, this is what separated South America and Africa from each other. And this is called a divergent plate. So what happens with a divergent plate is it separates out from each other. The newest rocks are in the middle, and the oldest rocks are closest to the shore. Okay, and then the third one is where they're going to pound into each other. It's like two cars crashing into each other. And depending on the size of the cars or trucks, depends on what type of reaction we get. But when they can put together, that's called a convergent plate, where they're going to bang into each other. And sometimes we get volcanoes, and sometimes we get mountains, and sometimes we get one that will crash underneath them, and that's called a subduction zone. Okay, so as we go throughout, again, make sure you got transform plate, make sure you got divergent plate, and convergent plate. Okay, now we're going to learn about the convergent boundary. Since this seems to be the most active, or kind of makes our world what we kind of look at like it today. So the convergent plate is where, in this particular picture here, we have an oceanic crust. Okay, and we have a continental crust. And when the oceanic crust crashes into the continental crust, this is like a big tractor trailer, and this is a little car. And what happens is it has no place else left to go, so it goes underneath. So that oceanic crust tends to be denser but thinner. Okay, and then the continental crust. And when that happens, it forms a subduction zone, or it's called subduct when it subducts underneath. So it subducts underneath. And that subduction that occurs can cause many different things. One, it can cause these really deep, deep ocean trenches. So if you ever watched Finding Nemo, remember when he lost the goggles down the big, long trench, and Dory says, we just keep swimming, swimming, swimming. That's where they went. They went down one of those deep trenches. If you've ever seen volcanoes, that's where they form an arc. They might form an arc, like in the coast of Alaska forms one of those arcs. And you just might see volcanoes that also occur. So what we're doing here is the oceanic crust tends to be younger and more dense. And with it being younger but more dense, it's going to subduct underneath the other one. And you can click on these different parts right here and get the full definition, or you can just write my simpler one. It's up to you, whatever you'd like to do. But if you want to go to this website and copy and paste it, you can just copy and then click the right button and copy it, and then put that into your document for this. But what we want to talk about is, what is the subduction zone? So the subduction zone is this one underneath, that the land is being pushed underneath another continent. A trench is a very deep ocean valley, and the volcanic arch is a chain of electrons along volcanoes along the zone. In this picture, we have an oceanic. A would be pointing to the oceanic crust, and B is pointing to the continental crust. So I'll give you a moment to write those things down or copy and paste them down onto your documents. And remember, you can always pause this video and be like, I need to catch up, all right? Because I tend to move a little fast. Okay. Now, when we go further down in that website, we see another type of continental crust. So continental and continental, this is another convergent, and these are like two cars coming at each other, the same shape, the same size, the same density. And what happens is they crash into each other, and we get mountains as a result. So when two of them collide together, it's often called the collision zone when this happens. We get we get big mountain ranges like the Himalayan mountains, the Alp mountains. Those type of mountains, they're continuously growing. They say that Mount Everest actually grows about your pinky length or about the amount of your hand every 10 years. So that mountain, you may climb the tallest mountain of the world today, but it may be different next week, depending on how much collisions are occurring between these two plates. Okay, so that one is continental and continental. I have a really hard time spelling continental, so I copy and paste that as much as possible. Just saying. I always forget an E or an A, or I don't know what I forget. But all right, next one, we're going to go through the divergent plate. So the divergent plate is where what happens is we're going to hit start right here. Kind of see this happening. All right, magma's kind of going up. The plates are kind of moving apart, and as they do that, the ground gets further and further apart from each other, and eventually you get a lake in between with volcanoes on either side. Now, this is occurring in the middle of our Atlantic Ocean, so we actually have volcanoes underneath the ocean, and then we have this really deep trench through the middle. But the newest rocks are right here in the middle, and the oldest rocks are furthest away from the original magma that came up. So on our thing right here, at a divergent plate boundaries, the tectonic plates are moving away from each other. As a result, it's called seafloor spreading when that happens. So when in the Atlantic Ocean, if that is occurring, then that is occurring. They're finding that the seafloor is actually getting wider and wider. Every year, we move away from Europe about the size of the pinky. So not very much, but over thousands of years, that's pretty significant. That's a lot of pinkies next to each other, and that is sort of significant. And then this plate right down here is a transform plate, and you guys don't actually have to write anything down for that, but the transform plate is where they're going to slide past each other. All right, slipping and sliding past each other. And that can often cause very big earthquakes, because when they slip a little, and then they completely slip past each other. Okay, so now the rest of this is sort of just review. So it says identify the transformations at the boundaries in each diagram. So what do we get when we get an oceanic and continental crust converging together? So we get deep ocean trenches, and over here, the volcanic arch that happens. So that's what happens when you get an oceanic and continental coming in. One's going to subduct underneath, and we get this big trench that happens, big, deep part of the ocean. But then we also get some volcanoes along the coast. Okay. The next one is if we have two oceanic crusts crashing into each other. Okay. What happens there is you get trenches and you get islands. That's what's happened in the Caribbean. So if you've ever been down to the Caribbean, it's a very old plate. So they really don't have a lot of active volcanoes down there, but you can get these arcs of islands that happen. And you can kind of look at the Caribbean islands and see where there's an arc, almost like a rainbow that occurred. And again, they don't really move that way. Right now, they're actually in a transform plate, that their plates move back and forth like that. So the question 2, trenches and island arcs are responsible for the oceanic and oceanic crust crashing into each other. The next one is a convergent boundary, so where two land masses crash into each other and we get mountain ranges as a result. All right, big mountain ranges. So the Rocky Mountains occurred because of this. The Alps are responsible for this. The mountain range that goes all down along the side of Chile and the Himalayan mountains are also responsible for these. All right, then we have transform, and transform occurs in our California. That would be on the United States, where we're going to have another earthquake. Will probably be on the California coast. Okay, and this is where they would move past each other, and that sudden jerk of land is often called an earthquake. And we measure that with seismic graphs. We measure how big it is with a Richter scale. And they can often be very detrimental. Okay, and the last one, what is this type of boundary right here? This is called a convergent, because one is going underneath another. We get a volcano, so that's a convergent plate. And this one where it slide past each other, that's a transform plate. And the last one, they're going to spread away from each other, and that's called a divergent. All right, that's it for the web quest. We're done, okay? Before break is coming, we're gonna have a quiz, and I promise it's not gonna be much harder than what we just did. Maybe a couple more questions, but I promise you'll be very well prepared for it, okay? Thanks for watching. Have a great day. Bye.